Hello everyone, welcome back, and today we are with the another Learn With Me live today. So welcoming you all for the new video. So in this video we're gonna cover the difference between the vector search libraries versus the VectorDB. You might heard the name of VectorDB in most of the generative AI applications right now. If you want to upload your database, say upload your knowledge base into your generative AI applications, and that applications wants to answer your questions based on the document what you have provided. Say an organization has been built, and if any other users want to ask any questions regarding the organization, so they might have all those things inside their organization files, etc., stuff like that. So the answers will be hidden so it will be available in the in the documents, and the chatbot what we are trying to build wants to try to focus on the answers. So this is a short intro behind what VectorDB is all about. But as a note, right, as the thumbnail or in the introduction field what I've just mentioned, so what is gonna be like the difference between the vector search library versus the VectorDB, and which one is gonna be the best one for the commercial use and why? As you guys might guess that VectorDB is gonna be the best one for the commercial use, but you need to know what is the difference between those two things. And today we're gonna have a demo on vector search library, one of the famous vector search library from one of the pioneering company, right, which is available open source, where we can able to use it and we can able to start knowing it. So we're gonna build simplest rag, I should say. We're gonna build some simplest rag, and we are trying to focus on it, right? That's the major stuff. And let's get into the session. And So the agenda of the session, why? Because since this is new, right? Why? Because so far in our sessions we talked only about like the in the first session in the Learn With Me live, we talked about the base of generative AI, and we talked about the transformers models. And in the second session we just dived deeply into the Llama architecture, Llama 2 architecture, Llama 3 architecture. Then we moved into some hands-on point of view. We tried to create a serverless event-driven architecture with the help of Bedrock. And our third session, which was Bedrock Access using CloudWatch, and fourth session was Amazon Bedrock Studio, where we have delved into a workspace where the builders and explorers share their GenAI apps, and we can able to work with the playground what Bedrock Studio has been access for us. And but that's not more focused, right? But because we haven't talked about, like, we talked about only the services, and I have shown you the the hands-on of Amazon Bedrock Studio workspace. So in this thing, what we're gonna show, what we are gonna discuss is all about what Retrieval Augmented Generation is all about. If you guys know, then it's gonna be very much easy for you. If you guys don't know, then it's gonna be why? Because I'm not gonna talk much about Retrieval Augmented Generation. The very simplest one, which will help you to understand what RAG is all about, how to build your RAG systems, and then followed by what are going to be the embedding models which are available. So first thing, we're going to talk about what RAG is all about, and the second stuff is all about what are the foundation models available for your RAG systems. And third is all about the difference between the vector search libraries and the VectorDB, what is going to be the main motto of the session. And we're gonna see some examples of vector search libraries and VectorDB, and I'm gonna show you one example which is called as ANNOY. So approximate nearest neighbors, OY stands for some other thing, but I'll show you at the last. I've added that. So we're gonna have a demo of it, right? So I'm gonna show you that in the in my Jupyter notebook, and how I built the simplest RAG with the help of the vector search library, and we try to focus on the point of view. So let's get into it. So what Retrieval Augmented Generation is all about? I've given you some a picture in the left hand side. You could able to see that's the simplest form what I've taken from the AWS docs, which is gonna be the the simplest form of RAG architecture. where for you want to use very simplest thing is that if you want to build a chatbot, right, that answer questions based on your documents, like your organization document or your study notes. Say if you're gonna create for your CS documents, stuff like that. If you're gonna have an entire book, right, you want to create a chatbot for your book, and that is gonna be right. Are we gonna focus? Are we gonna create a chatbot for what? Because it's an entire book which consists of almost 500 to 700 pages, maybe leading to 1000 to 2000 pages, etc. Stuff like that. So how are you gonna build a chatbot? Why? Because if you guys know, the general foundational large language models are built at the public databases. Okay, a publicly available benchmark databases. If you just go back and chat with chat GPT, you could able to get the output, right, because it has been updated with some kind of knowledge base, some kind of data which has been available publicly. And that is all about the code too, right? Because they might add a lot of data to it. So that's what the pre-training process of large language model does. So, but if you guys want to create a chatbot for your purposes, say if you based on your documents for your knowledge bases, then the answer for your question is gonna be the Retrieval Augmented Generation. Why? Because as I said, like unfortunately, the nature of the LLM technology introduces unpredictability in LLM responses. And moreover, as I already said, the LLM training data is static and introduce a cutoff date on the knowledge it has. So that's what I said. So it is static. We can't able to update it dynamically when it is in training. But after training, yes, we can able to create something called as RAG architecture, where we can able to import our knowledge base so that the model will be working on our data on our knowledge base, and the large language model with the derived form of the data will help us to provide a beautiful generated text output for the query what we're gonna provide to it. Right, so if you just see in the left hand side, so that's gonna be the RAG output. So say a user will giving you a prompt with a query what is to be solved for the chatbot, and what the system does, the second system does is nothing but it will give the query to the knowledge bases, and it will extract the information, the match information. Why? Because the data will consist of lot of variations, lot of categories. We need to check that where the query, the category which matches the query which is being asked by the user. So once the retrieved information, right, for the query is being done, we will give both those things like the prompt, the query, and the relevant information what we have got from the knowledge base to the large language model. What large language model does is that it will try to create and generate a text through the help of it, and finally gives us the output. So this is going to be the RAG, where the large language model will going to work on the relevant information extracted from the data knowledge base, but more efficient. It is going to provide you an enhanced text format for a better viewability. So this is going to be the conceptual for this diagram. I have drawn it, and this is what, like, when you are gonna build your LLM model, right? You could able to see this last part we are already seen in the previous slide, but this very important stuff, how we are gonna do it. That's the very important stuff, right? So say you guys have a document, say of a document. So what you are supposed to do, you have to chunk the document into pieces, like the pieces of text. So you can also chunk in terms of sentences, chunk in terms of paragraphs, chunk in terms of the topics, categories, etc. Stuff like that. But today we're gonna have a look how we're gonna chunk a document with the help of like splitting the we're gonna splitting that into paragraphs, splitting that into the sentences, and we're gonna have a look how it's gonna work. So once we are chunking the whole document, we are gonna embed the document, embed the chunks what we have been created. You could able to see embeddings are nothing but like the numerical format of the chunks. So chunk 1 will be derived into some numerical format, chunk 2 will be in the numerical format, and etc. and stuff like that. Why? Very important stuff is that the large when we are trying to make sure that since it is in numerical format, we can able to extract the nearest information that matches the query what we're going to do. Once it is done, we're gonna store the chunks in the VectorDB. I have precisely mentioned it as a VectorDB over here. Why? Because this is gonna be the, what can I say, the enterprise edition of the Retrieval Augmented Generation point of view. So once we're going to store the chunks in the VectorDB, now it's part of the user. The user will ask the input query, and the input query will be what can I say, changed into embeddings, and that embeddings will be given to the VectorDB. Now what the process does is nothing but the questions, the embeddings, what we have the question which is being converted into the embedding will be compared with the chunks to embedding inside the VectorDB, where we're gonna run a nearest neighbor algorithm. Say we're gonna work with the approximate nearest neighbor algorithm. I have said at the beginning itself, but because this is gonna be we are gonna discuss at the end, like the algorithm called as ANN, approximate nearest neighbor algorithm. So where we're gonna find the nearest vector which matches the embedding, which matches the question query, the query embedding, right? So that we are gonna retrieve the, what can I say, the nearest embedding that matches with the VectorDB. Once we are matched with the VectorDB, you could able to point number 6, then plus input query, we're going to go to the LLM model. You may have lot of foundational models. Say you're going to work with Claude 3.5 Sonnet, Claude 3 Opus, etc. stuff like that. There are a lot of, why I'm specifying Claude 3.5 is that it is the newest large language model released by Anthropic, which is very faster, very what can I say, lower in cost, and you could able to see it as a multi-model view on a point of view. So which works with vision like text, images, videos, and stuff like that. It actually looks amazing, and you could able to give that to the large language model, and the large language model will produce the output based on the query which has been asked by the user. So this is nothing but the entire conceptual flow of the Retrieval Augmented Generation. Now I'm going to show you some foundational models for RAG systems. I'm not going to show you like this one, which is nothing but for this LLM model, because you could able to use any kind of LLM model which does the text generation point of view, you could able to do. And if it is going to be, if the input query consists of image, and if you want to work with the image, you can also work with the, what can I say, image generation models too. But I'm going to show you the best embedding model what you can able to use it, right? And what are all the list of embedding models available in the town, and more specifically available in Amazon Bedrock, right? So because it's very simple, you can able to call through one single API and we can able to work on it, right? The first thing is the Amazon's Titan Embeddings G1, which is a text embedding. Second thing is all about the Titan Text Embeddings V2 text. And first, Titan embeddings is only available in English, where you can able to embed only English. Second thing, right now it is in English, and it is in preview for multilingual context. Third thing is all about Titan multimodal embedding G1 for multimodal purpose. Say if you're gonna embed your images or embed your something else, right, some extra, you can also embed that thing too. And fourth one is embed English from Cohere. So that thing we are going to use it today. Why? Because I'm not going to use Amazon Bedrock, but I'm going to show you how we can able to use Amazon Bedrock. So please do follow, right? If you can able to if you are following me in LinkedIn, so you could able to see a blog post from me, like how we're gonna invoke the vector search library with the embedding models from a Cohere API with Amazon Bedrock and the Amazon Bedrock embeddings too, right? We're gonna just have a look at just a simplest look of it. And the fifth model from the same Cohere, like which is fourth one is all about for English. Fifth one, like the embed multilingual from Cohere, which is for multilingual text. And I'll have a link. I'll give you the link in the description box. Why? Because you guys might have heard about it. But if you haven't heard about it, please take a look at the MTEB, the Massive Text Embedding Benchmark, which is being created to see the latest embedding models for the different use cases and the different languages. I'll give you the link in the description box. Please have a look. It's a Knocking Face website. You can just have a look at what are the different embedding models are available. I just show you only 5. There are a lot of other foundational, maybe I should say the word foundational, and some of the, or may say, in the testing phase of embedding models which are available in the market. Now let's get into the discussion. Why? Because so far so good, we talked about what Retrieval Augmented Generation is all about, and the conceptual flow of Retrieval Augmented Generation is all about, and then we talked about the foundational models which is available inside the for embeddings, right? For making to embed the documents, embed the text, embed the paragraph, etc. Stuff like that. Now, let's have a look. Like, what is the difference between the vector search libraries and VectorDB? But I wanted to show you something else extra. First of all, before knowing what VectorDB and what vector search DBs are, before that you need to know about what is the idea of the vector embeddings. Okay, so what is the idea of vector embeddings? Why it is very important to convert our chunks of documents into vector embeddings? It's very important, right? If you're gonna work with any kind of semantic search or similarity search of the document, say if you're gonna use a Google search, you're gonna put a query, and that query is gonna retrieve some answers. So not only that, it's gonna retrieve almost 100 of answers, and each and every answers will have some distance where the most prioritized answer will be seen in the first part. So which has a less distance. That means the distance between the input query and the retrieved query will be retrieved response will be lesser. So that's what I would say that's what the technology which is running behind the Google search, right? So what's the stuff all about, right? So why do we need to convert that into a vector embeddings? It's very simple. When you are able to convert that into a vector embeddings, you could able to use the vector distance function. Say if you're going to use an Euclidean distance function, very important, which is equal to the square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. I have taken only two data based on the two data points x1 x2, x1 y1 and x2 y2 in the sample space. You can also take number of data points if I'm going for z, etc., which you can also put it with that in the summations. Or you can also use the cosine distance formula, which is the cos of theta is equal to the dot function of a dot b, a and b divided by the norm of a into norm of b, where norm of a will determine the magnitude or the length of the vector, So it's now you could able to see like what is the major use of converting the chunks of documents into vector embeddings, so that we could able to use this distance function formula, any kind of formula, right, based on the use case. So that metric depends upon you. You can either use Euclidean, either use cosine, either use angular. There are a lot of distance functions you are going to use it. So that will help us to find the nearest vector to the query vector what we have asked. But have you ever thought about it? Because you could able to see a document will consist of huge vectors, right? So since the chunking will make based on the paragraph, if I say, and the document will consist of almost hundreds of thousands of paragraphs. If I gonna do a chunks in sentences, then it is gonna go for almost 1 lakh to 2 lakh number of sentences. Then it is very difficult to calculate the distance between, right? The distance between the query vector and each and every vector in the database. Now, how we are gonna, we're gonna speed up the process. We are gonna speed up the process. That's what I said. It's very difficult. We are gonna speed up the process with the help of VectorDB. Why? Because then we able to put all those vectors, right, what we have converted, use everything with the help of embedding models inside the VectorDB, so that we can able to use the approximate nearest neighbor algorithm. Please go and have a look at what approximate nearest neighbor algorithm are. Let's wait for another Learn With Me live session. I'll post what approximate nearest neighbor algorithm is all about with some kind of annotations which will help you along. And where this approximate nearest neighbor algorithm, which will help us to search through the vectors in the tiny fraction of the time. And a very important thing, the ANN will be working in the vector databases as well as in the vector libraries to simplify the job. Now, but still the question has not been resolved, right? Why? Because everything is okay, right? You have said about why we need to convert the chunks of documents into vector embeddings, but you haven't come to the conclusion. What's the difference between the vector search libraries and VectorDB? Whether they are same or different? I'll answer to the question in the next slide. So first, let's talk about what vector search libraries are all about. Why? Because I would say VectorDB is the successor of the vector search library. Okay. So moreover, what vector search library is all about that? Vector search libraries will store your vector embeddings in your in-memory databases or in-memory indexes in order to perform the similarity search for the input query vector. Okay, since it is in memory indexes, I'll give you a pass at the end after learning what vector search libraries is all about, to make sure that what is the key advantage of it. But because when you just see, right, what is the advantage of vector search library, you guys can't able to find what is the advantage. Why? Because each and every point will be the disadvantage of disadvantage for the commercial point of view. So now what is going to be like, most of the vector libraries will share the following characteristics. The first characteristic is nothing but they will store vectors only. They will not store any kind of associated objects that is being generated from the embedding models. Say, I'll show you something. So when you run a query, right, so your vector library will respond with the relevant vectors and object IDs. Why? Because we have to extract the relevant vectors and the object IDs from the from the DB what we have stored. But this is limiting. Why? Because we just need only the relevant vector, not the object IDs, right? So to solve this problem, what we're gonna do is nothing. You are supposed to store the objects in the secondary storage, say, and another storage, so that you can then use the returns ID from the query and match them the objects to the understand the result. So that's what we're gonna do in the hands-on point of view, where we're gonna return the index and we're gonna match it with the secondary storage what we already have, so that just make sure that like the index finding from the array. That's the point of it, right? That's why we could able to say vector libraries will store vector only. Second stuff is all about the immutable data. That is, when you push your data inside your vector library, then they are not immutable. That means the indexes are not immutable. This means that once you have imported your data and built the index, you could not make any kind of modification. That is, no new inserts, no new deletes, or no new changes. If you want to, like, if unfortunately you have done some mistakes, or if you want to add any kind of new data, then you have to rebuild it from the scratch. Only at one time you could able to build the vector library. If you want to build it another time, say if you want to add any kind of insert, add any kind of data, then you have to build it from the scratch. So this is gonna be one of the major disadvantage, guys. Why? Because the organization data, let's talk about the commercial usage, right? So if it is gonna be for commercial usage, then it is gonna be really difficult. Okay, why? Because the products updates might be weekly ones or daily ones, so we can't able to build each and every we can't able to build the vector library each and every day. So that is going to be very difficult thing. And the third thing is nothing but query during import limitation. That is, you can't able to query your data while importing your data. That means, say, if you are while importing your data inside your vector library, and if you ask a question to the model, it will not allow you. Why? Because it will ask you to require all. It will ask you to require. It will ask you to import all the data objects first. First and foremost, you have to import all your data objects first. Then only you could able to ask a question. But this is also one of the biggest disadvantage. Why? Because we can't able to wait until all the objects like will be imported into it. We need to just have some kind of simultaneous interaction with the database what we're gonna conduct. So these are all of the disadvantages. I would say these are all of the disadvantages of the vector libraries, and these disadvantages has been carried over and resolved by the VectorDB. Right? But you could ask a question. So then what is going to be the advantage of vector search libraries or vector libraries? That, as I said, I'll give you a parse, right? Just think about it. What is going to be the advantage of it? I've shown you that is that, like, since we are storing our vectors in the in-memory database, so it is very, very easy to set up, right? It is not so complex as storing your vectors in VectorDB. It's going to be very easy, and it is going to be fast to access. It's very at fraction of time you can able to access your vectors from the vector search libraries. And that is going to be now, since like vector library doesn't have the new inserts, no new deletes, or no new updates, but VectorDB, the core advantage of vector database is nothing but will have the full CRUD support. That is, they create, read, update, and delete. That solves the limitation of the vector library. And moreover, the databases are more focused on the enterprise level production deployments. As I said, I've answered the question at the first itself. If you want to use a rack system in an enterprise level production deployments, then your VectorDB is going to be your absolute choice. And as I said, it's gonna store vectors and objects, so you can able to store both data objects and vector. Since both are stored, you can also combine the vector search with the structured filters. And what happens is nothing but these filters will allow you to make sure the nearest neighbors matches the filter from the metadata. Why? Because only with the help of the filters, you could able to find the nearest neighbors. So, and it also supports the CRUD operations of the VectorDB, which is the HNSW, which is from VB8. Just have a look. I also post the link in the description box. Just have a look. That hierarchy navigable small word. And the second stuff is all about, right, the real-time search, right? Because you don't want to wait until all the data gets imported, right? So, and in the middle, you can also ask a question, and that query will be retrieving the relevant information. And the very important note that your queries won't return any objects that are not imported in, as you can't query what you don't have. That's very important. Unless until if you don't have a relevant vector present inside the VectorDB, you can't able to retrieve the relevant vector. So this is nothing but the difference between the vector search library versus the VectorDB. Now you might ask a question, so what's gonna be the use case for vector search library? Is nothing but a very small application, right? So if you're gonna build a very small application, say your organization is very I should not say in terms of organization. So say you're gonna build a chatbot for your own production life cycle, stuff like that. You can go opt for vector search library, but for the enterprise level, then VectorDB is gonna be the best option for you. Now I'll show you some examples of vector libraries in VectorDB. So the first thing, the vector libraries, you could able to see the Fires database from the Facebook. As you can able to see, the Fires database has been used to search the relevant vectors with the L2 or dot product vector comparison. You can just think of the mind bar, because what Facebook was being used for as a general social messaging platform. And moreover, we can able to give a friend request to the new users. So that's nothing but it will find the friends which are more relevant to you. That's the very important stuff. And go for the second thing, where we're going to use today the ANNOY, the approximate nearest neighbors OA, which is from Spotify for music recommendation. Why? Because I usually like rock metal songs and some of the melody songs, and I also follow some kind of artists like the Campbell and Alan Walker, stuff like that. So you could able to see my recommendations is based on the people. So it will Spotify has huge content of creators and huge authors, right? So now based on my query, based on my viewing of music, it will try to extract the relevant vector that has been present inside the Spotify. But I don't think that right now Spotify is using the same thing. And third thing is all about the scan, which is the scalable nearest neighbors from the Google. You can able to think about that, which runs behind the Google search. And the fourth thing is all about the non-metric space library, which is the NMSL-lib, where the efficient similarity search library and a toolkit for evaluation of your KNN methods. As you guys know, if you are a machine learning person, KNN is an algorithm which is being used to find the nearest neighbors, the K nearest neighbors based on the K different classes. And now let's go for the vector databases. I've just given you only the 4 different, but there are a lot: Pinecone DB, VB8DB, Chroma DB, and recently Rockset. If you have seen my LinkedIn post, Rockset is in open search. It's an open source vector DB, multi-model vector DB company, which was acquired by OpenAI recently. Not only this, there are a lot of other databases available in AWS too, where you can able to use OpenSearch and serverless options, stuff like that. Now let's have a look at the demo, right? Because I want to show you the demo that will help you guys to know about what vector search library is all about. So I've created a demo here. You can able to see my Jupyter notebook. So first, I'm going to use the Cohere API. I've created an API key in my Cohere account where I'm going to use the Cohere embedding model. So that's the major step I'm going to do it. So that's the thing. You can also use the embedding model from the Bedrock, like the Amazon Titan Text embeddings, where I've given you the code below, right? You can able to use this embedding models to work on. So let's start invoking it. Let me install the Cohere thing, Cohere API. Now let's have a look I'm gonna import some kind of relevant libraries which is needed for me, which is the OS, but because I've stored my core API key in the .env file to invoke that. Now let's invoke the .env file from the core, and I'm gonna create a core client. Now we're gonna use the ANNOY index. From ANNOY, import ANNOY index, and I'm gonna import NumPy and pandas to make sure to give you some kind of relevant these are some relevant libraries you can able to work on it. Yes, so this is gonna be my text. So you can able to take this as a knowledge base, because you could able to see the knowledge base context. The knowledge base context is nothing but the Wikipedia page of Martian. If you just have a look right after I just go and take the movie Martian. If you guys seen the movie Martian, please try to put that in the comments below, but because I have seen, it's a very interesting movie, but because you could able to see he's the one who's been what do I say, astronaut, right, who's been struggles in Mars, and how he survives from Mars to Earth is the concept of the movie. Like, it's a very interesting scientific movie, and this is what the content what I have here. So, and we're gonna work with that thing. So now let's import that. And now I'm gonna say, so this is the first step. This is the database, the knowledge base what we have. First thing, we're gonna chunk the documents. So the chunking can be based on the list of sentences, maybe the list of paragraphs, and let's see what is the difference in when we are chunking the documents, while we are chunking into a list of sentences or chunking into a list of paragraphs. So when we are chunking into a list of sentences, you could able to see each and every sentences will be listed as each and every chunk. But it's very important. Why? Because you could able to see that each and every sentences, and that is gonna help us a lot. And if you want to chunk into terms of paragraphs, I would say you can also go like this. Like, each and every paragraph will be considered as one single chunk. But unfortunately, why I'm not going to use the chunking as a paragraph is that you could able to see that each and every line has each and every information. Say this line says that it is in which year the movie has been released, what genre is it all about, who's the director, and who's star. And in the second line, it just shows about like who's the screenplay, and third line tells about who are the co-actors acted in the film. So to make sure that each and every input query may depend upon the different three questions. So we don't want to chunk that into one single context, so that we don't want to end up with some kind of things. So I'm gonna make sure to chunk with the split of sentences. But just go back in terms of split of sentences. This is the sentences in chunks of sentences what we have. Just have a look. In this first thing, The Martian is a 2015 science fiction film directed by Ridley Scott and starring Matt Damon. And Drew Goddard adapted the screenplay from the 2011 novel of the same name by Andy Weir. As a user from this side, I could able to see like Drew Goddard is the screenplay writer for the movie Martian. But according to the mission, we are not expressing that as a right or wrong. Why? Because you could able to see go down. The film depicts an astronaut struggles to survive on Mars after being left behind on NASA efforts to return him on Earth, which is the film. So now as a user from this side, we could able to know the film is nothing but Martian. But the system wants to know, the model wants to know what the thing is all about. So we are going to add a prefix to this particular point of view, where I'm going to add the title called as The Martian for each and every chunk what we have created. Now you could be able to see The Martian. The Martian is a 2015 action film, science fiction film, and you could be able to see for each and every chunk the word Martian has been added as a prefix to it for our better understanding for our model. Now chunking is done. The first step in the architecture is done. Let's go for this next second step, which is nothing but embeddings. I'm going to use the coher embedding model to embed your chunks, and third step, I'm going to convert that into an NumPy array, and you could able to see there are totally how many chunks are there. Okay, so with the length of this chunks is going to be 15 cross 4096. You could able to see there are totally 3 4 5 6 7 8 9 10 11 12 13 14, there are 15 sentences available in our knowledge base. So that's going to be the 15 plus 4096 going to be the embedding shape. Now is going to be our concept. Now we're going to add that. We have done the second step, that is we chunk the database and we have created the embeddings of the chunks what we have created. The next step is going to be we're going to store that into the vector library. So here I have used the ANNOY index. So from the ANNOY index we are supposed to pass the shape of the embed, which is the 4096, and the metric. Here I have used the metric called as angular, and you could also use Euclidean or Manhattan distance or cosine distance, etc. For my particular point of view, I have used angular. Now the search IDX is gonna be our ANNOY index. Now let's add each and every vectors from the embeddings to the search index. So I'm gonna run a loop on the embeddings, and I'm gonna add an item like the it's very important. I'm gonna add the ID, like say the index plus the embeddings. Then I'm gonna build it for the 10 thing, and I'm gonna save it inside the file called as sample.ann. Now let's think. So now it's done in a very fraction of a second. It is done. Now let's run. So why? Because I'm not going to use any large language model over here to run some efficient thing. You can also use it, but I'm not going to use it. Why? Because that's going to be an additional thing. You can use it. Now this is going to be for the search thing. So that's going to be from the search point of view. Now this is the query what we're going to ask, where the query is going to be embedded, and once the query is being embedding, I'm going to use the search index to find the nearest embedding. So first the search index dot get NNS by vector, the nearest neighbors by vector, and the query embeddings of 0, where we're gonna pass the embeddings of the query. Yes, it is. 3 is nothing but it will maximum find best 3 nearest neighbors, and we also include the distances as E2. You're gonna see the distance in the output too. Then we're gonna format the results inside the pandas, or if you don't want, you can also do it, and I'm gonna print the text. Now let's run. Now let's go for the queries what we have. So the query is nothing but I've just asked 2 different queries, that is when was the film released and how many awards it got, and second query is nothing but who is the producer of the film. So you could able to see the film was released. You could able to go back to the the knowledge base. You could able to see the film was released in the UK on September 30, 2015, and in the US on October 2, 2015 in 2D, 3D, IMAX 3D and 4DX. So this line also gives us the output, and this line also gives us why, because you could able to see. But fortunately, let's see what is the output it is gonna generate. So it is gonna generate, it was nominated for 7 awards, but because we are also asked awards, it is nominated for 7 awards at the 88th Academy Awards. You could able to see the distance, which is 1.0, that's gonna be the nearest one. And the film premiered at 2015 Toronto International Film Festival in September 11, 2015, and actually it released all those things, right? I could able to see, and due to the performance and yes, somewhat I could able to see a nearest output has been gone. And who is the producer of the film is going to be the next question. Let's go back to the knowledge base. The producer of the film is gonna be, right, the Simon Kinberg, okay? But the produce here, the line also says the produce thing. So let's buy, because we are not adding some kind of things. Okay, let's have a look. We are not adding any kind of LLM generated text. I'm gonna retrieve the relevant context from the database what we already built. Let's have, so the film was produced through the 20th Century Fox in the United Kingdom and in the United States, and the producer is gonna be like the Simon Kinberg. You could able to see the distance is not so huge, like 0.8 difference is gonna be there. So this is nothing but is all about the vector search libraries, and non-important. It is not mandatory that you want to work with the coherent embeddings, because I want to introduce coherent embeddings to you for the first time. But you can also work with Bedrock Titan embeddings by importing that through Langshan community. Wait for my blog. You'll have a look at the you'll have a look at the Bedrock embeddings to work with this vector search libraries too. Now, based on this query which has been resulted, right, these things, you can pass this query, pass this output, to the LLM to generate the enhanced results for the content which is going to be created. So we have created the simplest RAG for you, which will help you in the best cases, right? So I hope you guys might have learned something new from this Learn With Me live. So thank you for watching, and if you guys not followed me in LinkedIn, so my LinkedIn ID is Rahul Gopal, and if you see that my headline is the AWS Community Builder and ML and GenAI. I work with AWS Community. I work in GenAI part, and I'm an AWS Community Builder. And if you haven't subscribed to my newsletter yet, which is there in LinkedIn, where the name of this newsletter is also Learn With Me. So where I post latest GenAI releases with GenAI research papers, so which will help you to traverse what are the newest releases in generative AI and AGI in the time, right? So thank you for listening, thank you for watching, have a good day, and let's see you in the next video. Thank you.